Hi, this is Mrs. Robertson, and today we're going to take part 1 of our test. But before we do so, let's review a few things that you might encounter on your test. All right, simplifying fractions. This is something you all should know how to do, and I know that this is something that you will encounter on your test in just a little while. So let's look at these problems and see how could these simplify. 6/20. How could that simplify? Someone raise your hand. Tell me, how could I simplify 6/20? Yes. Right, we find the greatest common factor between 6 and 20, and there is one. It is 2. 6 divided by 2, and 20 also can be divided by 2 perfectly. 6 divided by 2 is 3. 20 divided by 2 is 10. 3/10. Give me a thumbs up. Are you good at this? I thought so. Let's go on to the next one. 3/2. How could 3/2 be simplified? It is an improper fraction, by the way. So how could I simplify 3/2? Yes. 1 and 1/2. How many 2's live in a 3? 1. How many's left over? 1. 1 and 1/2. Awesome. Now look at the third one. Notice how it progresses a little more with a little more of a challenge in that problem. What's another name for 2 and 5/3? Another name for 2 and 5/3. What's happening? You're looking at it, it's like, it's a mixed number. I don't see anything that can happen. But look closely, kids. What is 5/3? It's an improper fraction. Another name for 5/3. How many 3's live in a 5? 1. How many's left over? 2. 1 and 2/3. So add the whole number 1 to the whole number 2. And what's another name for that fraction? 3 and 2/3. Awesome. Any questions? All right. So everyone's good with simplifying fractions. You should get all of those problems right. Wonderful. Now there is a section on the test that you're going to take today is about vocabulary. All right. These are the words that you need to be familiar with on the test. What is a fraction? A fraction is a number that represents part of a whole. A number that represents part of a whole. And that's what a fraction is. The numerator is the part and the denominator is the whole. The whole amount. Okay? All right, so an example, 2/3. You have 2 parts of 3. Does that make sense to you now? Do you think you can remember that definition? A fraction is a number that represents part of a whole. Part of the whole amount. Got it? Okay, everyone knows an improper fraction, right? Now, on the test, the wording is a little different. This is what you would encounter. It says, when dividing fractions, it says, change mixed numbers. It is helpful to change, when dividing fractions, it says it is helpful to change mixed numbers to improper fractions. To improper fractions. So it's like the definition goes here. When dividing fractions, you change mixed numbers to, but they don't say you change. I should probably put you. They say it's helpful to change mixed numbers to improper fractions. So the key here, dividing fractions, mixed numbers go to improper fractions. I'm just going to call it IF here. Okay, I don't have room to write it. You got it? It's not going to give you, say, oh, 4/3. No, it's going to say you do this when you divide fractions. Numerator, it's the part of a fraction that tells how many you have. The numerator is the part of fraction that tells how many you have. How many you have of the part. How many units that tells how many units units the fraction contains. Those are the words on the test. So a numerator tells how many units you have. That's true. The part over the whole. The denominator, this is an easy one. In 7/13, 13 is the denominator. You can all get that one right, right? A reciprocal, they give an example. So an example, 4/5 reciprocal is 5/4. You're all good at that, right? A mixed number is a whole number and a fraction. What's a mixed number? A whole number and a fraction. Any questions on the vocabulary that we have here now? All right, the word problems are going to be things you're going to work on after we're done with the part 1 of the test. Now, let's see, where is there room to put these problems that I want you to do? You might need to get another piece of paper. I'm going to put a few problems up on the board that show you how to multiply and divide fractions. Okay, and I'll just keep these up on the board when you take the test. Is that all right? So you can reference them. All right? Now, tomorrow I won't have any references up on the board for you. So just make sure you know how to do this. Okay. All right, so when you multiply fractions, if I have 1/2 times 4/5, okay? You multiply straight across, but I like to simplify before you multiply. So I would do 2 divides 2 once and 2 divides 4 twice, okay? Then I get 1 times 2 is 2, 1 times 5 is 5, 2/5, okay? Another way you could do it is like this. This is the same problem. 1/2 times 4/5, 4/10, and then simplify it afterwards. And what will divide a 4 and a 10? 2, and you get 2/5. Do you see how to do that problem? There are 2 ways. You could do it this way or that way. Any questions? Another example for multiplying. Let's say I have 5 times 2 7s. All right. What do I do when I have a whole number and I'm multiplying? Yes. Right. You will have 5 over 1 times 2 over 7. I don't see. Huh? A bell? Oh. Thank you. Oh, let me turn this screen back on. I have the recording going again. And so we're going to go over how to do the word problems at this time. So let's just focus on these. Write everything down so you know what to do. And maybe circle or highlight things. That'll be helpful. Callie decided to fertilize her field. It requires 5/4 of a bag per acre. If Callie buys 15 bags, how many acres can she fertilize? Well, she has 15 bags, and it takes 1 1/4 or 5/4 of a bag to fertilize it. We need to divide. We're going to do 15 divided by 5/4. All right? So you're going to change that to an improper fraction, or 15. You're going to write it as a fraction. So let's put a 1 under the 15. Now you're going to keep, change, flip. 15 over 1 times 4/5. Any questions on that? There is a shortcut. 5 divides 5 once, and 5 will divide 15 3 times. Remember, you can only do the shortcut when you change it to a multiplication problem, all right, kids? Don't do the shortcut until you change it to multiplying. Now we multiply. 3 times 4 is 12. 1 times 1 is 1. So, let's read the question. How many acres can she fertilize? 12 acres. Any questions? This is a division problem. Okay? Everyone good with that problem? Let's go on to number 4. Rachel has 15 yards of fabric that she will cut into 3/4 strips. How many strips of fabric will she have? The key word here is cut. When you see cut, that means you're probably going to subtract or divide. And in this problem, you're going to divide. Okay? You're going to divide 15 by 3/4. 15 divided by 3/4. How many 3/4 are in a 15? Okay? Now, let's write that as a fraction. 15 over 1 divided by 3/4. That'll be 15 over 1 times 4 over 3. Everyone's okay? Not until we're done. This is really important. If you can wait, if it's an emergency, you may go, but this is pretty important. Now, I do have a shortcut again, don't I? Yes. 3 divides 3 once, and 3 divides 15 5 times. Now, 5 times 4 is 20, 1 times 1 is 1, and the answer is 20 strips of fabric. Now, these problems you'll do on a sheet of paper. They won't have the problems written out. You'll have a piece of paper, and it's cut up into 9 pieces tomorrow, but it's mainly word problems, and then you put the answer into Mastery Connect. Any questions on what that division problem looks like? When you see the word cut, you're going to usually divide or subtract, okay? All right, let's close our computers now because this is important. If you're working on another class, stop and do these problems. Number 5. Tom found 6/7 pounds of blue rocks. His sisters found 5/7 pounds of crystals. I like crystals. They used 4/7 pounds of the crystals for an art project. How many pounds of crystals are left? Do we even need to know about the blue rocks? No, that's unnecessary. We don't need to know anything about blue rocks. We're focusing on the crystals. What do we do to figure out how many pounds are left? Not divide, it's the other one. Subtract. Are left usually means you're going to subtract, okay? So, you had 5/7. You used 4/7 for an art project. What fraction do they have left? Yes. 1/7. 5/7 minus 4/7 is 1/7. Any questions on that? All right. So always be aware. Sometimes on word problems they put in information you don't need. Okay? Any questions on that problem? Well, good. Let's go on to the other problems on the back. Amy has a small box to use to fill a planter with gravel. You can tell Mrs. Robertson, I wrote this, I like rocks. The box holds 2/3 of a pound of gravel. So that little box holds 2/3 a pound of gravel. How many pounds of gravel does the planter hold if it takes 13 full small boxes of gravel to fill it? So, what do we do to figure out how much gravel she put in there? Yes. Not divide. Multiply. Or you could add 2/3 13 times. Okay, there are 13 of these little small boxes that she fills up. She fills this box up 13 times to put in the big planter. All right, here's the big planter. It's not a beautiful job, but there's the planter. So there are 13 of these boxes, and this box is 2/3 of a pound. So you take 13 times 2/3. You got it? Or you could add 2/3 13 times, but you don't really want to do that. So 13 over 1 times 2/3, that'll be 26 over 3. How many 3's are in a 26? You can look at the chart if you don't know up there in the front. Yeah, 8. 3 times 8 is 24, so how many's left over? 2/3. 8 and 2/3. So how many pounds? 8 and 2/3 pounds of gravel in that container. Okay? Or, as I said, you have 13 of these. They're 2/3. You could do 2/3. You could add 2/3 13 times. And you'd still get the same answer. You'd get 26 over 3. 1, 2, 3, 4, 5, 6. How many of them do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got one more scoop of that box. Now, this says the same thing as that. And when you add these all together, the 3 stays on the bottom. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I get the same answer, don't I? Yeah, it's a lot easier to do it this way. And that equals 8 and 2/3 pounds. But it's a concrete way of thinking. Every time she'd scoop that thing in and put more rocks in. Scoop it up, put rocks in. Okay? Now we're doing the pumpkin pie. Renee is baking a pumpkin pie. The recipe calls for 3/4 a cup of pumpkin. How many cups of pumpkin are needed for 5 pies? Well, what do you do for 5 pies? You times it by 5. 3/4 times 5. We'll gently pick the 5 up and put a 1 under it, right? 3 times 5 is 15. You get 15 over 4. So how many, let's change that to a mixed number. How many 4's are in a 15? 3. And that's 12. 3 left over. She needs 3 3/4 cups. Any questions? So 15/4 equals 3 3/4 cups. Now, this time she only wants to make a little baby pie. 1/3 of a pie. She's going to make a little bitty baby pie, maybe like a cookie. How many cups of pumpkin are needed for 1/3 of a pie? Well, what do? We do the same thing, don't we? You take 3/4, but instead of times a whole number, you take it times the fraction. You would get 3 over 12, and that simplifies to 1/4. She just needs 1/4 of a cup of pumpkin for a baby pie. Now, I could have simplified before I multiplied in this problem, and I would have gotten 1/4 right away. The 3's turn into 1's, and I get 1/4. See how to get that one? So that's the answer for 1/3. That's the answer for 5 pies. And it makes sense, you know, for 5 pies, if 3/4 a cup for 1 pie, it's going to be bigger. Now we have time to do our last problem here, I think. This problem, it says the teachers at Kitley are sorting toys to give away. An hour ago, their box was 11/16 full. So here's their box, and it's this full. Okay, this is 11/16. Since then, they gave away half of the box of toys, so half of 11/16. What fraction of the box of toys do they have left? You take 1/2 times 11/16. All right, and you get 11 over 32. Any questions? Okay, on your paper, the end, all I want you to do do the top 8 problems. Do this row and this row. They're very friendly numbers, okay? So do, on the end, the top 2 rows. Have a great day, and I'll see you tomorrow.